All right, welcome back everyone. Today we're going to talk about quadratic equations and the quadratic formula. So in this section you're going to learn how to solve quadratic equations using the quadratic formula and how to solve higher order equations that we can reduce to quadratics. And this is going to somewhat reference the previous two sections. So the quadratic formula, we start with a basic quadratic function, ax squared plus bx plus c equals 0, a basic quadratic equation. And then we use completing the square, we can find a solution for x. Now, the solution is what's known as the quadratic formula. This will solve all quadratic equations. When in doubt, you could always use the quadratic formulas. If factoring or completing the square is too hard or you're not good at it, always default to the quadratic formula. It will solve everything. It will always work. So we want to solve this equation using the quadratic formula. I'm going to write the quadratic formula up here. Negative b plus or minus the square root of b squared minus 4ac over 2 times a. When we're looking at this function, remember that we're using the form ax squared plus bx plus c equals 0. So in this case, for this equation, what we have is 3x squared plus 8x plus 3 equals 0. For this equation, a is equal to 3, b is equal to 8, and c is equal to 3. And so we're going to take the quadratic formula and just plug in all the numbers. And we get x equals negative b plus or minus the square root of b squared minus 4 times a times c over 2 times a. Now in this case, when I'm writing the quadratic formula, I just replace all the letters with parentheses and then fill in the appropriate numbers. So a is 3, b is 8, and c is 3. And now it's just a matter of simplifying this down. Multiply everything out, work through all the math. We get negative 8 plus or minus the square root. 8 squared is 64 minus 4 times 3 is 12 times 3 again is 36 over 2 times 3, which is 6. So we get negative 8 plus or minus the square root. 64 minus 36 is 28 over 6. Now at this point we're close to the right answer, or close to the answer in general, but we're going to have to simplify this thing. And this is where the quadratic formula can become challenging. So what we have is negative 8 plus or minus the square root of 28 over 6. The first step to simplifying this is to simplify the square root. So the square root of 28 over 4 times the square root of 7. 4 is the largest perfect square that will divide evenly into 28. And so we're going to get 2 times the square root of 7. And we're just going to replace the square root of 28 with that. What we get is minus 8 plus or minus 2 times the square root of 7 over 6. Now we can write this out by just writing everything over 6. Negative 8 over 6 plus or minus 2 times the square root of 7 over 6. And now we're left just to reduce these fractions. 2 will divide into 8 and 6. So this becomes 4 and 3. 2 will also divide into 2 and 6. And that's going to give us 1 and 3. And so what we get is negative 4 thirds plus or minus square root of 7 over 3. Or negative 4 thirds plus the square root of 7 over 3. And negative 4 thirds minus the square root of 7 over 3. All right, let's try another example. We want to use the quadratic formula to solve this problem. We've got 5x squared plus 3x is equal to 1. When we use the quadratic formula, we want everything on one side of the equation. And so we're going to subtract 1 from both sides, and we get 5x squared plus 3x minus 1 is equal to 0. And so in this case, A is 5, B is 3, and C is negative 1. And so if we use the quadratic formula, negative b plus or minus the square root of b squared minus 4 times a times c over 2 times a. A is 5. B is 3. And c is negative 1. And so if we multiply everything out, we get x equals negative 3 plus or minus the square root of 9 plus 20 over 10, which is negative 3 plus or minus the square root of 29 over 10. But the square root of 29 can't be simplified in any kind of way. 29 is prime. Okay? So we have to just leave it as the square root of 29. So that means we really can't simplify this thing at all. And so our answer, negative 3 over 10 plus the square root of 29 over 10, and negative 3 over 10 minus the square root of 29 over 10. Both of those are your answers. So the square root can be simplified, then it's likely that you won't be able to simplify the equation much at all, or at least the solutions much at all. Now, some equations can be reduced to look like quadratics, or in some cases you can factor things out so that they appear to be quadratics. Many of these problems will involve a factoring technique as opposed to using the quadratic formula, but the quadratic formula would still work in this case, just like it would solve any of the quadratic equations. So here we have 3y cubed minus 5y squared minus 2y is equal to 0. Now, first of all, we're going to have 3 solutions when we're finished. And now each one of these terms has a common factor. They all have a y. And so we can factor the y out. And when we take a y out, we're left with 3y squared minus 5y minus 2. So y times 3y squared minus 5y minus 2. Now 3y squared minus 5y minus 2, we can factor this. If you do not recognize that you could factor it, you could use the quadratic formula to get those solutions. We already here have one solution. And I'll show you that whenever we're finished factoring. And so let's factor 3y squared minus 5y minus 2. So take the first number and the last number and multiply them together. 3 times negative 2 is negative 6. We want to make a box. And in that box, we're going to write the coefficient both times. Split the variable up, y and y. And now we need 2 numbers that add to give you negative 5 and multiply to give you negative 6. In this case, that would be negative 6 and positive 1. Now remember, if we can reduce one of each side like a fraction, we should. There's nothing that can be done to this left-hand side. One of our factors is 3y plus 1. But both of these over here are divisible by 3, and so we divide them by 3, we get 1 and 2. And so our other factor is y minus 2. And so if we go back to the original problem, now we have y times y plus times 3y plus 1. equals 0. And so what we have is the multiplication of 3 linear factors. And so we would do the same thing here that we would do if it was just 2. Take each piece and set it equal to 0. Well, we get y equals 0. Y minus 2 equals 0, which if we solve that, we get y equals 2. And then 3y plus 1 equals 0, which if you solve that, you get negative 1/3. And so we have 3 solutions for this equation, 0, 2, and negative 1/3, which is what we expected when we have y cubed at the beginning of the problem. So this technique just involves factoring out a common factor and then factoring the trinomial that remains. If we try another example, now we have x to the 4th minus 3x squared plus 2 equals 0. Now this thing's not quadratic, but it's set up to look like a quadratic. And so to solve this, we can still factor, but our factoring has to be just a little bit different. If the problem were x squared minus 3x plus 2, and we were to factor it, following the same steps, we would get 2, 1 times 2. We would set up a box, 1x, 1x. We need 2 numbers that multiply to give us positive 2 and add to give negative 3. And so negative 1 and negative 2. And so our factors, x minus 1 and x minus 2. And we can do the same thing for this one here. It's going to work out to be very, very similar. Take the first number and the last number and multiply them together. We're going to get 2. Make ourselves a box, 1 and 1. Now we want to split the variable up, but since it's x to the 4th power, we're going to get x squared and x squared. The rest of it still holds the same, negative 1 and negative 2. We add them together, we get negative 3. If we multiply, we get positive 2. And so our factors, x squared minus 1 and x squared minus 2 equals 0. Now, although these factors aren't linear, we can still set them equal to 0 and solve. But we're going to have to use the square root property. I'm just going to go to the next slide. We've got x squared minus 1, x squared minus 2 equal to 0. We're going to take each piece and set it equal to 0 separately. We can add 1 to both sides, and we get x squared is equal to 1. If we take the square root, we get x equals plus or minus 1. Remember, when we take the square root of a number, we get plus or minus. And so there's 2 solutions. X equals 1 and x equals negative 1. Now we want to do the same thing for the other equation. Add 2 to both sides. We get x squared is equal to 2. Take the square root. X is equal to plus or minus the square root of 2. The square root of 2 doesn't simplify. And so we get 2 more solutions, the square root of 2 and negative square root of 2. We started off with x to the 4th, and we finished with 4 solutions, and that's what you would expect. You should have 4 solutions for any equation that is x to the 4th power. So, at the end of this lesson, you should be able to solve a quadratic equation using the quadratic formula. You should be able to solve a higher order equation by factoring it down to quadratic.